Okay, guys, this is problems from lesson 82. I'm going to turn off that light just so we don't have a glare. There we go. The first question was practice problem E, lesson 82, page 340. All right, here is the problem. And it wants to know the domain and the range. Remember, the domain is the all possible x values. The lowest possible x value is at x is -1. But because it has an open indicator, x cannot equal -1. So x has to be greater than -1. And the last x value is at 5. So x has to be less than or equal to 5. Less than or equal to because it's a closed indicator. So the domain is all reals. Domain is all reals such that -1 is less than x is less than or equal to 5. Now the range is our y values. The lowest y value is -1, sorry. So y has got to be greater than or equal to -1. Notice the closed indicator. So y goes all the way from -1 up to positive 3. So y has to be less than or equal to +3. So the range is all reals such that -1 is less than or equal to y is less than or equal to 3. Okay, so that's number E, well, letter E, practice problem E. The next question was problem 1. I'll move my book. We'll go to the board. Problem 1 reads, find. Got to open my marker just a minute. All right, here we go. Find 4 consecutive odd integers. So the 4 consecutive odd integers, this is number 1. Remember, the first one is n. The second one is n plus 2. The third one is n plus 4. Trying to get this situated here. The fourth one is n plus 6. All right, so this is the first one, second one, third one, fourth one. All right, big problem. Such that 6 times the first and the third, 6 times the sum, remember we open a bracket, times the sum of the first and the third, the first one is n, the third one is n plus 4, is equal sign, 3 more, remember we add our 3 back here, then 5 times the opposite. When it's 5 times the opposite, I'm going to say it's -5 because negative means the opposite. So we're multiplying by a negative, we're multiplying by 5. Opposite the fourth, which is n plus 6. Okay, so then we use distribution. Distribute the 6 to all of the terms. In the parentheses, to eliminate parentheses, it's 6n plus 6n plus 24 equals, now I'm going to distribute the -5. -5n minus 30 plus 3. At this point, I'm going to combine my like terms on both sides. So I'm left with 12n plus 24 equals -5n minus 27. I'm going to move my n's to the left through addition. And I'm left with 17n plus 24 equals -27. I'm going to subtract my 24 on both sides. 17n equals -51. Divide by 17 on both sides. N is -3. I'm not done. It wants 4 consecutive odd integers. So -3, -1, 1, and 3 are the consecutive odd integers. Okay? All right, next number, 7. Number 7. All right, so number 7 reads, here's my function, f of x equals x squared plus 1. It wants to know what f of x plus 1 equals. So this is what I'm inputting for the value of x in this equation. So for this x, I'm putting in x plus 1. And the value of x, which this is now the value of x, is squared plus 1. So f of x plus 1 equals this x plus 1 squared is the binomial times itself. I FOIL the binomial, and it is x squared plus x plus 1 plus this 1. I combine my like terms. X plus x is 2x. 1 plus 1 is 2. So f of x plus 1 equals x squared plus 2x plus 2. Next one is number 8 from lesson 82. Number 8 says, find the domain. So I'm finding the domain of g of x equals square root of 4 minus x. This is one of our limitations on the domain. What's under the radical? That 4 minus x has to be greater than or equal to 0. So solving for x, I subtract 4. I have negative x greater than or equal to negative 4. I don't want to know what the negative of x is, so I multiply by negative 1 on both sides. When I multiply by negative 1, the direction of the sign changes, so I have x is less than or equal to 4. So, what is my domain? My domain is all reals such that x has to be less than or equal to 4. Okay, so that's number 8. Number 9 says, what is the domain and the range? So we're looking for the domain and the range of this function, f of x equals negative 1. This is our y value. Y equals negative 1. If I graphed this, there's negative 1. The line would be a horizontal line. My domain is all reals. Remember, that's my x value. So my domain is all reals because it goes to positive infinity and all the way to negative infinity. Now my range only has one number. It's just negative 1 because the range never changes for this function. Now number 10 is in the book, so I'm going to go back to the book, and it wants to know the domain and the range. So looking at the domain, my smallest x value is negative 4, so x has to be greater than or equal to negative 4. My largest x value, it's a close indicator, my largest x value is positive 4, but it's not equal to it, so x is actually less than positive 4. So my domain is all reals such that negative 4 is less than or equal to x is less than 4. My range is my y values. The smallest y is negative 1. So, and it's equal to, so y has to be greater than or equal to negative 1. And it goes all the way up to 3. Now that's an open indicator at 3 here, but we have a closed indicator at 3. So that value 3 is included for y. Y less than or equal to positive 3. So my range is all real such that -1 less than or equal to y less than or equal to 3. The last problem for lesson 82 was number 13. So let's look at 13. 13, we have two equations. We have y equals 2. We have x equals -3. I want you to graph it and solve for where they are concurrent, okay? So, y equals 2 is a horizontal line. This is y equals 2. X equals -3 is a vertical line. So that's x equals -3. Where do they meet? Where do they intersect? They meet where x is -3 and where y is 2. This is the point where they are consistent, or in geometry we call it concurrent.